Hi guys, welcome to Gatematic. In all the previous lecture, we have covered the single phase fixed voltage variable frequency as well as variable voltage variable frequency, that is the PWM concept. Okay, and after completing each and every concept related to single phase voltage source inverter, let us try to solve the previous year gate question that has been asked from 1991 to 2018. So let's get started. See the first problem. This has been asked in GATE 1999. A PWM switching scheme is used with the three-phase inverter. Although we have not studied the PWM three-phase inverter, but we can solve this question. That is, a PWM switching scheme is used with three-phase inverter to reduce the total harmonic distortion with modest filtering. Second, minimize the load on the DC side. Third, increase the life of the battery. Fourth, reduce lower order harmonics and increase higher order harmonics. So I already explained you that why we are going to for the PWM scheme. It reduces the lower order harmonics as well as it will increase the higher order harmonics, and as we know that higher order harmonics can be easily filtered out. So this is the advantage of PWM technique. The correct answer would be D. See the second question. Triangular PWM control when applied to three-phase BJT base voltage source inverter. Again, it is three-phase. No need to worry about that. Just see what is happening. It is PWM technique is done, and option is given, that is lower order harmonics voltage on AC side. No. What introduces PWM technique? It introduces higher order harmonics on the AC side. As we know that on AC side, I have already explained you that according to Fourier series expression, if I will do the PWM scheme, then overall lower order harmonics decreases and it increases the higher order harmonics on AC side, not on the DC side. So option D is correct. See the third problem. A three-phase voltage source inverter, although we don't know the three-phase, but we can solve this, supplies a purely inductive load is given. Upon Fourier analysis, the output voltage waveform is found to have a nth order harmonic of magnitude alpha n times of that of fundamental frequency component, where alpha n is the less than 1. The load current would then have an nth harmonic of magnitude what? Okay, so what is saying? It is saying that, see, the output voltage waveform is found to have nth order harmonic of magnitude alpha n times of fundamental frequency. So it is saying that output voltage V naught is equal to alpha n times of Bn. Okay, alpha n times of B1, where B1 is nothing but peak value of fundamental output voltage, alpha times of fundamental frequency component, that is B1. So output voltage is depending upon alpha n times of B1. Now I need to find the load current will be what? So as I know, load current IL will be equal to V naught upon n omega L. Why I am writing n omega L? As we know that here it is purely inductive load. So if there will be purely inductive load, then definitely the XL will be equal to n omega L, and n is the harmonic number. Now I can write V naught is equal to alpha n times of B1 upon n omega L. I can write like this. Means it is alpha n upon n multiplied by B1 is the peak value of fundamental voltage and omega L is the fundamental XL. Okay, that is the X1. So this will give me I1. Okay, so it is the load current is equal to alpha n by n times of peak value of current, that is the fundamental frequency component of current. So option D is correct. Got it? See the fourth question. A inverter has a periodic output voltage with an output voltage as shown in figure. When the conduction angle is alpha is given, that is equal to 120 degree, that is the pulse width. The RMS fundamental component of the output voltage is what? See, this is nothing but single PWM. Okay, and concept I already explained you. In single PWM, the pulse width of 120 degree it is given. This is my pulse width of 120 degree. So I know 2D is equal to 120 degree. This is given, so D will come out to be 60 degree. Now it is asking RMS fundamental component, means it is asking V01 RMS. So in order to write the V01 RMS, let us see the V naught of T according to Fourier series expression that I already found, that is equal to 4 VDC upon n pi into sine nd into sine n omega naught T. This is my Fourier series expression. So peak value of fundamental output voltage will be equal to 4 VDC upon pi into sine d, and if I will divide by root 2, then it will be We know V01 RMS. So 4 VDC upon pi into sine D divided by root 2 will give me V01 RMS. VDC here is 1 per unit, so it is equal to 4 multiplied by 1 into pi root 2 multiplied by sine D. D is equal to 60 degree. So solve this, it will be equal to 0.78 volt. So whatever I taught you, that is more than enough to deal any kind of problem related to GATE exam. So option A is correct. Now see the part second. This is the part second. With reference to the output voltage given in figure, the output of the converter will be free from fifth harmonic. As we know, I need to make V05 is equal to 0. So V05 is nothing but 4 VDC upon 5 pi into sine 5D, that is equal to 0. So from here 5D will come out to be pi. So D will come out to be pi by 5, that is 36 degree. So pulse width of 72 degree is required in order to make the fifth harmonic, that is equal to 0. So option A is correct. Got it? So in this way you can approach. See the next problem. This I have given you in the homework also when I taught you the lecture number, I think in lecture number 42C. Okay, I have given you the homework. The figure shows one period of the output voltage of an inverter alpha should be chosen such that it is lie between 60 to 90. If RMS value of fundamental component is 50 volt, then alpha in degree is what? So see, this is nothing but half wave symmetry as well as quarter wave symmetry, right? And 90 degree will be somehow here. So if it is half wave symmetry and quarter wave symmetry, then I can easily write the Fourier series expression n is equal to 135 up to infinite. This is equal to Bn into sine n omega naught t, where Bn can be easily found by using the short trick, that is equal to 4 VDC upon n pi into 1 minus 2 cos n alpha 1, or let us say here alpha is given, so it is n alpha. Okay, so this is my value of Bn and I need to find the B1 RMS. So B1 RMS that is given, that is equal to 50 volt. I can write B1 RMS that is equal to 2 root 2 VDC upon pi into 1 minus 2 cos alpha. Here VDC is nothing but 100 volt. So it is equal to 200 root 2 upon pi into 1 minus 2 cos alpha. So find the value of alpha. It will be equal to, I think, 77.15. It is approximately equal to this much. So alpha will be equal to this much. Okay. Now if you have not gone through my lecture number 42b and 42c, then what you will do, you will integrate from 0 to alpha, again alpha to 180 minus alpha, and 180 minus to alpha to 180, and so on. So it will be very bulky calculation. So apply the shortcut that I given you in the lecture number, I think 42b. You can apply this shortcut and within a fraction of second you can get the alpha, the value of alpha. Okay, this has been asked in GATE 2014 for 2 marks. So this is really important. So whatever the concept I am giving you, that is important for GATE point of view. So do not ask me whether this topic is important or not. Each and everything I am giving you, that is related to GATE syllabus only. Okay, I have not gone through the ES syllabus till now. Once I will complete the GATE syllabus, then I will take the some different topic that is only related to ES syllabus. Okay, so don't worry, watch the lecture from start to end. Each and every topic are in GATE syllabus. Okay, so alpha will be equal to 77.15 degree. See the next problem. I think you will have a problem in seeing the figure. Let me speak the question. A single phase voltage source inverter shown in figure feeding power to the load. The triggering pulse of the device are also shown in the figure. Okay, fine. And this is my triggering pulse. S1, S2 and S3, S4 are triggered something like this. This is my triggering of S1 and S4, and this is my triggering of S2 and S3. Okay, both triggering switch pulse are given, and if the load current is sinusoidal and is 0 at 0 pi 2 pi, the node voltage VA0 has the waveform. So this is my single phase full bridge inverter. Okay, and it is asking that what is the pole voltage, not the pole to pole voltage. They are asking VA0 and VB0. So if you have gone through my lecture, then you can easily say the VA0 will be continuous and it will start from here to here and it will move like this. It is fluctuating between plus minus VDC by 2. This is plus VDC by 2 and this is minus VDC by 2. So only one option is satisfying, that is option D. Okay, so option D is correct. See the next problem. This is also an important problem. Now we will understand the value of my lecture. A single phase full bridge voltage source inverter shown in the figure has an output frequency of 50 Hz, that is the fundamental frequency is given. it uses unipolar pulse width modulation with switching frequency that is equal to 50 kilohertz. Fine. And modulation index is given that is equal to 0.7. Okay. Input voltage given that is equal to 100 volt, and the value of L and C is given. The amplitude of fundamental component in the output voltage V0 under steady state will be what? Means it is asking here, this is my output voltage and this is equal to the V01 peak, it is asking. And this is at fundamental only, because we are talking about the V01, means it is at fundamental, means the frequency will be equal to 50 hertz. So in order to find the output voltage V0, here full bridge VSI is connected, and that is controlled by unipolar PWM technique. I have already explained you unipolar PWM technique, and I told you that whether it is unipolar or bipolar, the peak value of fundamental output voltage is nothing but it is depending upon the modulation index multiplied by VDC. I told you in bipolar also as well as unipolar also. This V01 peak is not here. This is not this one. This V01 peak is equal to here VR1 into peak, where VR is the voltage across this terminal, because after output of the inverter is here only. So once I got the VR01 peak, then I can easily get the V01 peak just by applying the voltage division rule. So V01 peak will be equal to M times of VDC. M is given 0.7 multiplied by VDC is given that is 100 volt. So it will come out to be 70 volt. So this is the mantra. I told you that this is really important. Once you got that this is unipolar or bipolar PWM technique, then you can directly apply this formula. Okay, and the derivation, how this is coming, you can go through the lecture number I think 43. You will understand how this is coming. Okay, so draw the equivalent circuit. This is my AC voltage having 70 volt. Here inductor is connected, here capacitor is connected, and here one R load is connected. Now this is the question of network, not the inverter part. Here value of R is given that is equal to 5 ohm, and XL I can easily find at fundamental frequency, because I am talking about the fundamental only. Okay, so at fundamental frequency it is equal to 2 pi F naught L. F naught is 50 hertz, L is given, so it will be equal to J3 ohm at fundamental. Similarly, XC will be equal to, if we find 1 upon omega C at fundamental, that will be equal to minus J into 50 ohm. Okay. Now you can reduce this circuit just like take the parallel combination of these two. It will be equal to 70 volt into J3. This is my XL. This is J3. And here the combination you will get something Z is equal to 5 multiplied by minus 50J upon 5 plus 50J. This will be not in plus, this will be minus. This is my value of Z, and here I need to find the value of V0. Now apply the voltage division rule in order to find the V0. V0, let us say this is my ZL. Okay, so V0 will be equal to supply voltage 70 multiplies by ZL upon J3 plus ZL. Okay, this will give you the output voltage, and it will come out to be 62.77. Apply the calci, use the calculator, that is a scientific calculator. You will get the output voltage that is 62.77. So here you have to put 62.77 volt. See the next problem. This is also related to pulse width modulation only, and see here it is written as the switches T1 T2. This is my half bridge inverter. I explained you with the help of full bridge inverter, but don't worry. The switches T1 T2 in the figure are switched in the complementary fashion with sinusoidal PWM technique. This is written that sinusoidal PWM technique is done. The modulating voltage Vm is equal to 0.8 sine 200 pi t. This is my 0.8 sine 200 pi t, and the triangular carrier wave Vc are shown in the figure. The carrier frequency is given that is 5 kilohertz, and the peak value of the 100 hertz component of the load current will be what? So it is asking V01 peak at 100 hertz. So first see whether this 100 hertz is the fundamental frequency or not. See here, modulating wave that is equal to 0.8 sine 200 pi t is given. So from here omega naught is equal to 200 pi, that is equal to 2 pi f naught. So f naught you will get that is equal to 100 hertz only. Means it is asking V01 peak at fundamental. Okay, and here sinusoidal PWM technique is done. Fine. And also the value of XL and R, here XL is given that is at 100 hertz. So XL at 100 hertz is given, that is equal to 16 ohm, and R is given, that is equal to 12 ohm. This is given, okay, and this is half bridge inverter. So I need to find the peak value of the load current, means I need to find I01 peak at fundamental, not V01 peak at fundamental, I01 peak at 100 hertz. This is the question. So I know I01 peak at 100 hertz is nothing but V01 peak at 100 hertz upon the value of Z at 100 hertz, right? You can write value of Z1. So V01 peak, I know in single phase half bridge or full bridge pole voltage, V01 is nothing but, see here, this is my A point and this is my O point. So pole voltage will give me the output voltage. So pole voltage, I already told you that it is equal to, peak value of pole voltage is equal to M times of VDC by 2. You can go through the lecture number 43 as well as 44. You will understand how I am writing this. So peak value of fundamental output voltage will be equal to M multiplied by VDC by 2 upon Z1, and Z1 is easily calculated by taking the load. Okay, load is given as 12K square plus 16K square at fundamental. Now I need to find the modulation index. So modulation index I already know, that is equal to VR upon VC. Here VC is given, that is equal to 1, and VR is given, peak value of VR is given 0.8. So modulation index I am getting, that is equal to 0.8. So write it here, 0.8 multiplied by VDC is given 250 volt upon under root 12K square plus 16K square will give you 20. So it is coming out to be 10 ampere. So answer of this will be equal to 10 ampere. So what I told you when I was teaching you sinusoidal PWM technique, that there in each and every problem they will ask you the peak value of fundamental output voltage or peak value of fundamental output current. So that is depending upon the modulation index, and the derivation I already explained you in the lecture number 43 and 44. Go through that and apply those concepts in solving the problem. Okay, so the answer of this question is 10 ampere. See the next problem. This is the last problem that has been asked in GATE 2016. After GATE 2016, there is not a single question asked from single phase voltage source inverter in PWM as well as 180 degree mode. So see the ninth problem. A single phase full bridge voltage source inverter is fed from the 300 volt battery. Okay, this is the full bridge. A pulse of 120 degree duration is used to trigger the appropriate device in each half cycle. Fine. The RMS value of fundamental component of the output voltage. So this is related to single PWM technique, and whose pulse width is already given, that is equal to one pulse width of 120 degree in per half cycle. That is something like this. And it is asking the RMS value of fundamental component of current. So V01 of t, according to Fourier series expression, I know it contains only odd harmonics into Bn sin n omega naught t, and Bn I got here, that is equal to 4 VDC upon n pi into sin nd, right? So peak value is asking, what is asking? The fundamental component of output voltage, the RMS value. So B1 RMS will be equal to 2 root 2 VDC upon pi into sin d. Just find the B1 peak and divide it by root 2. You will get 2 root 2 VDC upon pi into sin d. Here pulse width of 120 is given, so d will come out to be 60 degree. So B1 RMS will be equal to 2 root 2 multiplied by VDC. What is the value of VDC here? That is 300 volt upon pi into sin 60. So it will be equal to 233.9, that is equal to 234 volt. Okay, so option A is correct. So this much questions has been asked from pulse width modulation, single phase pulse width modulation or three phase pulse width modulation. I included the three phase question also because the concept will remain same, only the two more phase will come, that is exactly 120 degree displaced from each other. So concept will remain same, that's why I include the three phase PWM also, and that is all about the gate question. Now tell me, from question number 1 to question number 9, is there any concept that I have not given you? I have given you each and every concept related to PWM, and based on that you can solve any kind of gate problem as well as ES problem related to single phase PWM inverter. Okay, so just go through my lecture and believe in my lecture. Whatever I am giving you, that is more than enough to crack gate exam. Also make a short notes of each and every formula that I solved, I derived there, and try to revise each and every formula related to PWM inverter. Okay, so that's all about this lecture. In the next lecture we will see the ESE question that has been asked in prelims exam from PWM inverter. Okay, if you guys understood the concept, then please like this video, and if you are having any doubt, then you can ask in the comment below or join our Facebook group for doubt solving.